Alright, so in the past we've done direct proofs, but now we're going to talk about how to do an indirect proof. So you're still, anytime you're doing a proof, you're trying to prove that something is true. You come up with a conjecture or a guess of something that's a fact, and then you try to prove that it's true. With our direct proofs, we tried to go straight at it and prove that the conclusion was true. With an indirect proof, it works differently. With an indirect proof, instead, you begin by assuming that it's not true. And then you go through the steps to show that the fact that it's not true is not true. So it must be true. And kind of a roundabout backwards way. That's why it's called indirect. You're not proving it directly, you're going a roundabout way. Here are the steps for an indirect proof. The first thing you do is identify the conjecture. Okay, what are you trying to prove? The next thing you do is assume the opposite of that. 3, use direct reasoning to show that your conclusion your assumption in part 2 is not correct. And then what happens is then you say, well, if that's not correct, then my original assumption must be true. And I have an example here. So this is kind of a real life example. So let's say you had a conjecture, or maybe your parents said, if you get home past curfew, you will be grounded. Okay, and you wanted to prove that was true. Well, how could you prove it's true? If you come home before curfew over and over and over and over again, and you're never grounded, that really doesn't prove anything. So here you go, okay, if I get home past curfew, I'll be grounded. That's your conjecture. So then what we do is assume the opposite is true. So you would assume that if you get home past curfew, you're not going to be grounded. Okay, so that's how we'd use indirect. You assume that it's not the case. So then you test it out. You use reasoning and you say, okay, on Saturday night you stay out past curfew, and then you assumed if you stayed out past curfew you would not get grounded, and that was wrong. Your parents grounded you. Okay, so again, starting from the top. The conjecture we're trying to prove was that if you got home past curfew, you would be grounded. So we started by assuming that's not the case. You said, well, if I get home past curfew, I won't be grounded. You stayed out one night past curfew and you get grounded. Okay, which proves your guess right here in step 2 of the opposite was not the case. You did get grounded. So then that brings it back to, that proves that if you get home past curfew, you will get grounded. Okay, so they're a little different because, again, you're going backwards. You're assuming what you want to prove isn't true, show that that case can't be true, and that brings you back to saying, well, then my statement must be true. Hey, there are two things. So here's another example. If you wanted to prove that two lines were parallel, okay, the first thing you do is you say, assume they're not parallel. Okay, so this is an indirect proof. Then you say, well, the two lines should intersect if they're not parallel, right? If they're not parallel lines, they should cross. We're going to assume they're in the same plane. Okay, then you look and the lines never intersect. Okay, so that proves that they must be parallel. Okay, so you started out trying to prove two lines were parallel. You made the assumption of the opposite, that they were not parallel, tried to show that they were not parallel, but they never intersected, which means they were not parallel, which led to the fact that they were parallel. I know it seems kind of like a big circle, which it really kind of is. Okay, here are two other properties that will be in this lesson, and for some reason they threw them into this quiz here, so I thought I'd go over them. Okay, two other things we're going to work with. The triangle inequality says that in a triangle the largest angle is opposite the longest side. Okay, so the biggest angle is across from the biggest side, the smallest angle is across from the smallest side, and the middle angle is across from the middle length side. So in this triangle here, which is not drawn to scale obviously, okay, if we wanted to know where the longest side was, we could do it by looking at the angles. So 110 is the biggest angle here. So across from 110, this would have to be the longest side. This is a property that's been proven and is true. What's the next biggest? Well, 46 is bigger than 24, so that means this one would come next. And then our smallest angle was 24 degrees, so across the figure from that would be our shortest side. Okay, you can use it going the other direction also if you know the angles. It's a terrible drawing of a triangle. Let's say this is A, B, C. If you know the side length, so let's say we knew this was 10, this was 12, and this was 8, we could order the angles from largest to smallest or smallest to largest. Where's our longest side? 12 is our longest side, so across that side, this would be our biggest angle. So angle A would be the largest. Our next longest side is 10, so across from the 10, angle B, that would be our middle-sized angle. And finally, our shortest side, 8, across from that would be our smallest angle. Okay, so we use this so we can identify if we have sides or if we have angles, we can identify the opposite things, the angle or the sides, in order. Okay, the other one you'll study in this lesson talks about the possible lengths for a triangle. Believe it or not, there are lengths of sides that don't work to make a triangle. If you think about it, here's an example right here. If I had a side length 8, okay, and I wanted to make a triangle with another side that's 1 and another side that's 6, well, here's 1 right here, length of 1, and if I brought over this length of 6, it just wouldn't come quite far enough to make a triangle. They wouldn't meet up. And the reason for that is even if I lay them out flat like this and put a length of 1 here, a length of 6 here, notice there's still a gap in the middle, and that's if I totally collapse the triangle on itself. Okay, so there are limits. The way that we tell if 3 sides can make a triangle is that, here's our theorem, in a triangle, the sum of 2 sides of a triangle has to be greater than the third, and that's why if it's less than that, then they don't reach to make the triangle like we want them to. Okay, so to check, what you do is you add each pair of sides together, and they must be greater than that third side. So for here, we would be able to tell, well, we start with here 8 and 1 has to be bigger than 6, and it is. 9 is bigger than 6. Okay. Then we pair the next one, 1 plus 6 has to be greater than that third side, 8, which is not the case because we only get 7 here. We needed 8. So automatically right there, I would know that no, these cannot be lengths for a triangle. I'm going to go ahead and write out the third pair. The third pair of sides would be 8 and 6, and they just have to be bigger than 1. Well, they're both bigger than 1 already, so add them together, they're going to make it. So this was not correct sides for a triangle, and the reason was right here. The 1 and the 6 do not add to be greater than 8, which we kind of showed right here in a picture. So those are the properties we're going to study in this lesson.